My name is Ryan Schwent, and I did my presentation on the sport of baseball and specifically on measuring hitters and their batting average and exit velocity. Here, we're going to get into my presentation. So I did my presentation on does higher exit velocity translate to higher batting average? So for those who don't watch baseball, batting average is determined by dividing a player's hits by his total at bats. So for example, if you have 70 hits and 200 at bats, then your batting average will be 350. Same way, if you have three hits and 10 at bats, your batting average will be 300. And 300 is basically the standard metric by which any hitter is basically assumed to be a pretty good hitter. I mean, if you're hitting 300, then essentially you're a good hitter. And exit velocity measures the speed of the baseball as it comes off the bat immediately after a batter makes contact. And this particular statistic is basically tracked for every time the ball leaves a batter's, but every time a ball leaves a the bat, like everything is tracked, whether it's hits, errors, outs, foul balls, etc. Um, and hitting the ball hard or attaining the high exit velocity is one of the hitter's primary goals because if you're hitting the ball hard, then obviously the defenders are going to have less time to react to the baseball, so you'll have a better chance of getting on base. And right here, I have basically every player in Major League Baseball. So, I mean, you can scroll down this names. There's over 400, I believe there's 462 names of every player, their batting average, and their exit velocity. So you can see the average will be AVG, and the EV will be 97.60 here. And you can kind of see them listed in both graphs right here. Um, and my overall expectation when I was doing this project is that it doesn't really matter how hard you hit the ball. It more matters where it's being hit. Um, Hitting the ball hard only matters to a certain degree, in my opinion. But obviously, I'm pretty interested to see like what the data is going to show. And so, yeah, I'm definitely interested to see what the data is going to show. So when I was doing this presentation, one of the main things I was looking at is yes, one of the main things I was looking at in this presentation was I was looking at tiers of hitters and I was trying to see, I was basically saying that any good batting average is generally considered 280 and above, and any hitter that's hitting below 200, I wasn't really considering in this presentation because if you're hitting 200 or below, then you're really not hitting the ball hard and you don't have a high average. So it wouldn't really make sense for me to consider those hitters in this presentation. So basically, what I was looking at was three tiers of hitters. Tier one was hitters hitting between 200 and 240. Tier two hitters hitting between 241 and 279, and then tier three hitters hitting 280 and above. And so what I did is essentially took my data into SQL and I looked at okay, so how many hitters are hitting above 280? I found that 49 hitters were hitting above 280. Then I looked at how many hitters are hitting between 241 and 279. I determined that there was approximately 202 hitters hitting between 241 and 279. Then I looked at how many hitters are hitting between 200 and 240, and I found that there was 160 more hitters hitting between 200 and 240. I also looked at everyone with an exit velocity of over 90, which essentially means they're hitting the ball pretty hard. There's approximately 127 different hitters that had an exit velocity over 90. And the main thing I was trying to do, like with my original primary question, was does higher exit velocity translate to higher batting average? So what I did was I selected the average exit velocity of every hitter who's hitting above 280. And it gave me that the average exit velocity of hitters hitting 280 and above is 89.88 miles per hour. The average exit velocity of all the hitters hitting between 200 and 240 was 88.4 miles per hour. So you can already see that there's definitely a somewhat of a difference here, which is seeing that the players hitting 280 and above are hitting the ball a little bit harder than the hitters hitting between 200 and 240, for example. And then hitters hitting between 241 and 279 had an average exit velocity of 88.9 miles per hour. And I also kind of looked at every team, their average exit velocity, and also how many home runs they're hitting. It was kind of interesting to see, like, if you can look at the Atlanta Braves here, they hit 303 home runs and they had an average exit velocity of 90. Whereas you go at the bottom, you can see, the Rockies, for example, had 125 home runs and their average exit velocity was 87.8. So you can also tell that hitting home runs also hit, having a higher exit velocity also translates to hitting higher home runs, not just batting average. So going back to my presentation, um, basically the results of the sequel showed me that batters hitting 280 and above had an average exit velocity of 89.88 miles per hour. Batters hitting between 241 and 279 had an average exit velocity of 88.9 miles per hour. And batters hitting between 200 and 240 had an average exit velocity of 88.4 miles per hour. So you can definitely see that there's a difference between those. Then additional factors that could have potentially skewed my calculations a little bit are players that have high home runs and high strikeout totals, for example. So if you have a high strikeout total, you're likely going to have a lower batting average. But if you're hitting a lot of home runs, then you're likely going to have a high exit velocity. Then essentially my thoughts on the research were that the data shows that players that hit the ball slightly harder do tend to have a higher overall batting average. Through this data, it was surprising to find that higher exit velocity did typically translate to higher batting averages, which I found through SQL. And one other thing I want to go over was one of the graphs I put into Tableau that kind of showed the teams and their exit velocities, and you can kind of tell the difference between them. And one thing I did here was um, for people that don't typically watch baseball and maybe didn't know all the different teams, like I wrote some code in Python where basically you can see here, like it has all the teams like Detroit, Oakland, Chicago, etc. And I wrote, some strings of code to basically just rename the actual team names like Tigers, Athletics, White Sox, Marlins, Red Sox, Cubs, Brewers, Cardinals, Yankees, Twins, etc., which I thought would be more helpful for people to, especially for people that weren't fans of baseball, to know exactly which teams had which averages and exit velocities. And just want to show what I did with that. So you can see here how they're listed here. And then after I put in my Python code, you can see them. Now it's all the actual team names that were listed. And you can see their averages and their exit velocities, and just looks better in my opinion. And you can definitely very interesting, like to kind of see the differences between the teams. Yeah, that essentially concludes my presentation. And I was, like I said before, a little surprised to find out that the higher exit velocities did translate to higher batting average. I was not expecting to find that when I started my presentation.